Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new. Imagine relying on a tool every single day for your work, a tool that has fundamentally changed your productivity. Then, out of the blue, the billing model shifts and your monthly cost skyrockets, not by a little, but potentially by a factor of 20, 50, or even more.
That's precisely the scenario many developers and organizations are now confronting with GitHub Copilot. The era of the all-you-can-eat AI buffet, as some are calling it, appears to be ending, revealing the true underlying costs of large language model inference.
This isn't just a minor price adjustment. It sounds like a fundamental reevaluation of what these AI coding assistants actually cost to operate. What's driving this abrupt shift?
At its core, the change reflects the inherent economic realities of running sophisticated AI models at scale. When GitHub Copilot first launched, the focus was largely on adoption and demonstrating value. The pricing model was relatively straightforward, often a flat monthly fee or bundled into enterprise agreements. However, behind the scenes, each code suggestion, each line completed, translates into a computational query on a large language model. These queries consume significant GPU resources, and those resources are expensive.
So the initial model was essentially underpricing the service, perhaps to capture market share, and now the chickens are coming home to roost, so to speak.
That's a fair assessment. It's a common strategy in nascent technology markets. Offer an attractive, simplified pricing structure to encourage widespread adoption. But as usage patterns emerge, particularly heavy usage, the disparity between the revenue generated and the operational cost becomes unsustainable. For Copilot, the all-you-can-eat buffet worked well when there were fewer diners or when the cost per dish was less scrutinized. Now, with millions of developers relying on it and LLM inference costs remaining substantial, that model is no longer viable.
It raises a significant question about the true cost of these AI-powered development tools. The efficiency gains are often discussed, but less attention is given to the computational burden behind each suggestion.
Indeed, the core issue lies in the nature of generative AI. Every time a developer types a few characters and Copilot offers a suggestion, that's not a static lookup. It's a real-time inference request sent to a powerful, distributed language model. Think of it like this. Each time you ask Copilot for help, you're briefly spinning up a tiny, dedicated supercomputer to formulate that response. And unlike traditional software, where a license fee covers access to a static binary, here the product is generated on demand, dynamically consuming expensive resources with every interaction.
So it's not just about the upfront training costs, which are known to be astronomical, but the ongoing per-query cost that adds up.
Precisely. Training an LLM is a colossal one-time investment, requiring months of computation and massive data centers. But once trained, the model still needs to run to be useful. Each inference, the act of generating a response from the trained model, demands computational power, typically specialized hardware like GPUs. The more developers use Copilot and the more suggestions they generate and accept, the higher these aggregate inference costs become for GitHub. It's an operational expenditure that scales directly with user engagement, which is exactly what a successful product aims for, but it creates a challenging cost curve.
So it's not just about the upfront training costs, which are known to be astronomical, but the ongoing per-query cost that adds up.
Precisely. Training an LLM is a colossal one-time investment, requiring months of computation and massive data centers. But once trained, the model still needs to run to be useful. Each inference, the act of generating a response from the trained model, demands computational power, typically specialized hardware like GPUs. The more developers use Copilot and the more suggestions they generate and accept, the higher these aggregate inference costs become for GitHub. It's an operational expenditure that scales directly with user engagement, which is exactly what a successful product aims for, but it creates a challenging cost curve.
Turning to the new usage-based billing model, what does that actually look like for a developer or an engineering team? How are they now expected to pay?
The shift is towards a model where costs are more directly tied to actual consumption. While the specifics can vary, the general principle is that users will be billed based on metrics like the number of lines of code suggested, the volume of tokens processed, or the frequency of interactions with the AI assistant. For instance, some models might introduce tiers based on accepted suggestions or active usage minutes. This moves the financial burden from a fixed subscription cost to a variable operational expense, much like how cloud computing bills are structured, with costs fluctuating based on actual CPU cycles or data transfer.
That sounds like it could be a rude awakening for teams that have embraced Copilot extensively. It's one thing to budget a flat monthly fee, another to suddenly see unpredictable spikes based on individual developer habits.
It certainly is. For organizations that have deeply integrated Copilot into their workflows, and especially for highly active developers who might accept hundreds or thousands of AI-generated lines of code daily, the cost implications are substantial. Early reports from internal testing and pilot programs indicate that some heavy users could see their monthly bills jump from a standard flat fee to hundreds or even thousands of dollars per developer. This could force companies to reevaluate their entire developer tooling budget and potentially lead to difficult decisions about who gets access and under what conditions.
So, what kind of behavioral changes might be observed from developers and organizations as they grapple with these new costs? Will they just pay up, or will they start to be more judicious in their use?
A significant shift towards more cost-conscious usage is expected. Developers might become more selective about when and how they invoke the AI assistant. Instead of passively accepting every suggestion, they might be encouraged to type more of the code themselves or refine their prompts to get more precise, fewer token suggestions. For organizations, this could translate into internal chargeback models, where departments or teams are allocated a budget for AI coding tools, similar to how cloud compute resources are often managed. It might also spur a renewed interest in optimizing code generation, focusing on quality over quantity to minimize unnecessary inference calls.
It sounds like there's a shift from a world where AI assistance was a free-flowing utility to one where every interaction has a visible price tag. What are the broader implications of this for the AI coding tool ecosystem? Is this just a GitHub problem or a bellwether for the industry?
This is absolutely a bellwether. GitHub Copilot is one of the most prominent and widely adopted AI coding tools, and its pricing adjustments are indicative of a broader challenge facing all developers of LLM-powered services. The economic model for generative AI is still maturing. Companies building on top of foundational models from OpenAI, Google, or Anthropic are all contending with significant per-token or per-query inference costs. This means any AI tax GitHub is now imposing is really a reflection of the underlying infrastructure costs that all providers will eventually have on.
So are other AI coding assistants and even general-purpose AI tools likely to move towards similar usage-based models?
It's highly probable. The initial land grab for users, often subsidized by venture capital or larger parent companies, is giving way to a focus on sustainable unit economics. This will drive innovation not just in the capabilities of the models, but also in their efficiency. This could lead to a greater emphasis on smaller, specialized models that are cheaper to run for specific tasks, or a push towards local inference where possible, moving computation closer to the user to reduce network latency and potentially cost.
If this trend continues, what does it mean for the future of AI and software development? Could it stifle innovation, or will it simply force a more mature approach to resource allocation?
It's unlikely to stifle innovation entirely, but it will certainly shape its direction. There will be increased pressure to develop more efficient models, to optimize inference pipelines, and to provide greater transparency into cost consumption. This could lead to a more nuanced understanding of where AI assistance provides the most value and where human expertise or more traditional automation tools remain more cost-effective. There might also be a resurgence of interest in open-source LLMs that can be run on-premise or on a company's own cloud infrastructure, giving organizations greater control over their costs, albeit with the burden of self-management.
That's a fascinating thought. That cost could drive a new wave of open-source adoption, or even a move away from purely cloud-hosted AI.
Indeed. The promise of AI has been immense productivity gains, but the reality is that those gains come with a price tag. Companies will need to perform detailed cost-benefit analyses, understanding not just how much faster developers can be, but also what the actual per-line or per-feature cost of that AI assistance is. It brings the financial engineering aspect front and center for developer tooling, which historically has been an area where costs were often absorbed as a general overhead.
So, looking at the bigger picture, what are the key insights listeners should take away from this shift in GitHub Copilot's billing?
First, the free lunch or all-you-can-eat model for sophisticated generative AI tools is unsustainable in the long run. Second, the true cost of LLM inference is significant and will increasingly be passed on to the end users. Third, organizations must now factor in variable, usage-based costs for AI coding tools into their budgeting, treating them more like cloud compute resources. Fourth, this economic pressure will likely drive further innovation in model efficiency, cost optimization, and potentially a decentralization of AI inference.
And looking ahead, what questions should organizations and developers be asking themselves?
A primary question is, how will budgeting and development practices adapt to these new variable AI costs? And, perhaps more critically, will these changes in billing ultimately foster a more mindful and strategic adoption of AI, or will they simply create new barriers to entry for smaller teams and individual developers?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.